All right, welcome back to Algebra 2. Today we're looking at 6.4 inverse functions. Before we get into it, I want you to try a warm-up. So you can go ahead and pause the video and give these a try. All right, for this first one, it says solve x equals 4y cubed for y. So if I have x equals 4y cubed, and I'm solving for y, I'm going to go ahead and divide by 4 on both sides and get x over 4 equals y cubed. And if I'm trying to get y by itself, I'm going to do the inverse operation here. Take a cube root of both sides. So in the end, I'm going to get y equals the cube root of x over 4 for that first one. This next one, we have two functions, f of x and g of x, and it says what is f of g of x, and so that's a function composition that we learned before. And so this would be like, what is f of, and g of x is equal to x squared. So it's like taking the x squared and plugging it into whatever f of x is. Well, f of x is 4x plus 1, so 4x plus 1, but instead of that x, we're now we're just substituting in an x squared in there. So reducing this is not going to be too hard. We're going to get 4x squared plus 1, and that's it. For the next one, we have g of f of x, and so so we're going to plug into g whatever f of x is. Well, f of x is equal to 4x plus 1, so we're going to take 4x plus 1 and plug it into g of x. So g of x is x squared. So we're going to take this, or x squared, but instead of an x, we're actually plugging in 4x plus 1. So if we were to reduce this or simplify it, you could leave it like this. If you put it more into a standard form, you'd have 4x plus 1 times 4x plus 1, and you'd have to expand it. This would give you 16x squared plus 4x plus 4x plus 1. So in total, this would be 16x squared plus 8x plus 1. And this would be more of a standard form. And that top one, if you're talking about like a quadratic, it might look more like a vertex form, but that's how you do that problem. So today we're talking about inverse relations or inverse functions. And so a couple key terms here. An inverse relation interchanges the input and output values of the original relation. An inverse function, it's the same exact thing as relations. Except the equations are actual functions, right? Remember what a function is. It means that every input has exactly one output, and so inverses you've used many times before. The idea of inverse is that if you have a function or something that's acting on an input, the inverse is something that does the exact opposite. It brings you back to where you just came from. And to just show, what an inverse might look like, right? We talk about it mathematically, and you've actually used inverses quite a bit, right? When you solve equations, you're using inverse. You're using the opposite operation. But just to give you a visual, really, if you think about an inverse as doing the exact opposite, or kind of undoing the original action. So a couple of things, even just the undo button on your computer. So let's say you're typing, you're writing an essay, and then you make a mistake. If you hit the undo button or Control Z, that would basically reverse what you just did and bring you back to the original state that you were in. That would kind of be the idea of an inverse. And there's some YouTube videos here too of things that just look cool backwards or in reverse, and you can do that on different social media apps. But just to give you a visual, here is some videos of things that are in reverse, right? So if you're peeling an orange, what would be the reverse of that? What would be the inverse of that? Well, not possible to do an actual, in real life, but the video kind of shows it. There'd be the inverse. So all these videos that you're seeing and are on YouTube all over, you can see the inverses in action. You can think about, what was the original action? What was the original function? What was the original thing that happened to these things? And so I won't show you a bunch of these, but you can just YouTube them. There's a lot of them. This is Mr. Reverse on YouTube. Right, so you get the idea. All right, so inverses, that's kind of what we're talking about today. And inverses, like I said before, are used all the time, and you used them before. Mathematically, you can think of inverse as just opposite operations. Like very common ones would be, multiplication and division. Those are clear kind of opposites. Addition versus subtraction, right? So if you multiply by 3 and then immediately you divide by 3, then you're going to end up with the same original number. Or if you add 10 and subtract 10, you're going to end up with the same original number. So those are examples of inverse operations. You can also think of, if you square something, right? You have something and you're squaring it. What would be the inverse of squaring something? Well, it'd be taking that same thing and doing a square root, right? So we've talked about these types of equations. One of the useful things about inverse is that it allows us to figure out what the original was, or in math, it allows us to solve equations. Because if we have something squared and we want to figure out, well, what was that thing before it was squared? We can use the inverse operation and take a square root and figure out what that original thing was. And so there's a lot of different inverses here, and that's what we're really going to get into. So we used them before, but we're really going to focus on that idea of inverse today.